morning, class.
Good morning. Okay, so today we're going to be learning about scientific measurement, and the objective of the day is to learn how to master metric conversion, significant figures, accuracy and precision, percent error, sig figs, scientific notation, and SI units.
But what do those mean?
Which thing?
What do those mean?
Well, you'll learn what it means. If you don't learn what it means, then I don't know what to tell you. Alright, so let's start with SI units. There are 7 SI units we use. The first one is meter, and that's to measure length. The second one is kilogram, that's used to measure mass. Then we have Kelvin, used to measure temperature. We have second, that's used to measure time. Mole is for substance amount. Candela, used to measure luminous intensity. And ampere is used to measure electric current. So on the next slide, we have some examples here. 22 seconds, 35 meters, 62 kilograms, and 2.5 moles. So what is the full name of each of these units right here?
I can answer this one.
Okay. What is S?
Seconds.
Okay. Next one.
Meters.
Third.
Kilograms.
Fourth.
Moles.
The answers are correct: seconds, meters, kilograms, and moles. All right, next topic is metric conversions. And when it comes to converting, we use, I kind of like to think of it as a pyramid, but you can use the staircase method too. You go from kilo to hecto to deca, base unit, and then deci, centi, and milli. And we have this right here: King Henry died unexpectedly drinking chocolate milk.
What is the King Henry died unexpectedly drinking chocolate milk mean?
Well, anagram for when it comes to remembering each metric unit. So king, kilo, Henry, hecto, died, deca, and then
I think that's unit.
it's for base unit.
Yeah.
Drinking for deci, chocolate for centi, and milk for milli. So that's how you basically remember, kind of a good way to remember this right here. 1,000 millimeters is equivalent to 0.001 kilometers. 100 centimeters is equal to 0.1 decameters. And then 1,000 decameters is equal to 1 hectometer. So how many millimeters are in 1,000 micrometers? And move the decimal point to the left for bigger units.
I would say like maybe 10.
10.
That's my guess.
That's your answer, okay. And you are correct. There are 10 millimeters in 1,000 micrometers. All right, so now we have accuracy and precision, and these two things kind of get interchanged sometimes, but the difference is accuracy is how close the measurement is to the true value, and precision is how close the measurements are to each other, right? And the formula we use for precision for a range of numbers is highest value minus the lowest value. And we use this formula to determine if the range of numbers is precise or not. So this next slide, you see some examples of good accuracy, good precision, bad accuracy, bad precision. So this first one right here, you have the 3 dartboards. First one, this shows good accuracy and good precision. The second one, it shows poor accuracy, but you can see that all 3 of the darts are close to each other, so it's good precision. And then here, none of the darts are close to each other, and none of them are at this bullseye right here, so pretty not accurate. All right, moving on to percent error. This is what we use to determine accuracy. We use this percent error formula. The absolute value of experimental value minus the accepted value divided by the accepted value times 100. So the experimental value is what we get from basically our measurement, what we experimented, and then the accepted value is the actual value of whatever we're measuring, right? Have an example. The boiling point of water is found to be 98.2 degrees Celsius. Using the percent error formula on the previous slide, calculate the percent error of water, and here's a little hint. The accepted value of the boiling point of water is 100 degrees Celsius. So from that, find the percent error.
My guess would be like 2.8%.
2.8%? Okay.
Positive because it can't be negative.
Okay, Christoph.
I don't really know, but I'm a bit confused.
Oh my gosh. Okay.
Let's say, kind of 1% error.
1%. All right, so next slide, the answer is 1.8%. And remember, percent error is always positive, never negative, which is why we have the absolute value kind of symbol in the actual formula.
Oh, so that's what it means.
Yeah. All right, so next topic is scientific notation. And scientific notation makes it easier to work with larger numbers. And a number is expressed in scientific notation in the following form. C times 10 to the power of n, where C is a number between 1 and 10, n is an integer, and n is obviously the exponent. So here, see an example, 45,000 converted to scientific notation here. It's 4.5 times 10 to the power of 4. So now we have significant figures, and this is honestly my favorite topic out of the topics we've covered so far, or in the scientific measurement unit. Here are the rules for safe fix. All numbers from 1 to 9 are always significant. These numbers are called significant digits. So if the number is from 1 to 9, remember it is significant and called a significant digit. Zeros are only significant when it is sandwiched between two significant figures. So for example, 105. The 1 is significant, the 5 is significant, the 0 is sandwiched between the 1 and the 5, therefore it's significant. And then when it is a trailing 0, so when the 0 is trailing, so for example here, right, it's trailing the 2, it's trailing the 1. It also has to have a decimal point.